think I was saying the word critical values in the previous examples when I was going over them, like before I actually defined and talked about them with you. But critical value is when the derivative is either equal to 0 or undefined. So here, let me fill out these no, these are just the definition that is actually in the bottom of this page. So I'm going to fill out this definition part and go up and answer this question, okay? So definitions. A critical value of a function f is any number c in the domain of f for which the tangent line, can you fix that typo for me? It should say tangent line at c, f of c, is 0 for which the derivative does not exist, okay? That is, c is a critical value if f of c exists and the derivative at c is 0 or is undefined. Now look, in 3.1 and 3.2, we will mostly deal with that case, okay? When I ask you to find the critical value, you will set the derivative equal to 0, okay? You will find the critical value by setting the derivative equal to 0. And you practice that in actually unit 1, okay? But if I ask you to find critical points, because when you find critical value, you just find the x value at c, okay? But if I ask you to find critical point, then all you have to do is plug in that c, that x value, into the function and just write it as an order pair. So we'll do lots of practice of this today. But this second case, when the critical value exists for the derivative not defined, like that, the red case, we'll talk about that when we get to the rational functions unit in section 3.3, okay? But 3.1 and 3.2 will work with setting the derivative equal to 0 to find critical values. So in this example, they want us to find all critical values, okay? When is f prime of x equal to 0? Okay, when is the slope of a tangent line equal to 0? So you're looking for horizontal tangents, okay? So they're asking you to find horizontal tangent lines, okay? And I see a couple of them here. Look, they sketched the horizontal tangent at C1. So here's my first one. Horizontal tangent right there. And that value is C4. Hey, I forgot one right there. There is C2 right there. Anywhere you can draw these horizontal tangents, there's my C4. This one is C7. And last one at C8. So the points that we just marked, these are actually relative extrema. Relative minimum, you see the bottom of the U shape, or relative maximum, the top of this upside down U shape. So these are where the slope of a tangent line comes out to be 0. I'll read this. That is, the tangent line to the graph is horizontal at these values. These are called critical values, okay? These are called critical values. So if you want to find relative maximum or minimum, you start by finding critical values, okay? Because that's where the tangent line is horizontal, okay? F prime of x does not exist. All right, let me highlight this in blue. Now, this isn't really something we will do until like later. But if derivative is undefined, we still call them critical values. But when are these undefined? Remember, slope of a vertical line is undefined, right? So they're talking about vertical tangent in this case, vertical tangent. Or, you know, if we can't draw a single tangent line, okay? Remember, those cases will be like sharp corner. And I think I see a couple of the sharp corners here, like C6 is. But let's start with the places. Let's go find all these points where we have a vertical tangent. Well, I see a vertical tangent sketched right here for C3. Is there any other? No, actually that's it. So f prime of x does not exist for x equals c3. The tangent line is vertical at x equals c3. And there are corners, sharp corners. Where are they? Let's go find some sharp corners. At c6, see there's a very sharp corner, and c5, right? So c5 and c7. c5 and c6. Okay. I'll say f prime of x does not exist. For the purple one, they don't exist because there's not a unique tangent line. For C3, it doesn't exist because a vertical line has undefined slope. But for two different reasons though, but these three are the points where f prime of x does not exist. Okay? So, two cases really. If the derivative is equal to 0, or if the derivative is undefined, that's what we call critical values. Okay? So we'll use this to find relative minimum and maximum in the next couple examples. But like I said, this week we're doing more of setting the derivative equal to 0. And when we do the rational functions after spring break, we'll talk about how to find points where derivative is undefined.